All right, this is Physics Chapter 4, Lecture Number 1. In this lecture, we're going to go through on your own problems 4.1 through 4.4. So you'll need your physics book and your notes and a calculator. All right, so for the first two on your own problems, they are just like really what we were doing in chapter 3. There's only one more step to go through. So really nothing new. So I'm just going to go ahead and work these two problems for you. 4.1 says an airplane flies with a velocity of 214 miles an hour, heading of 65 degrees, including the effects of the wind, and the pilot stays on the course for 2.1 hours and then turns the plane so that it flies with a velocity of 187 miles an hour and a heading of 335 degrees, including the effects of the wind. If the airplane flies on that course for an additional 1.4 hours, what is the plane's final displacement? All right, so the only difference here is we need to convert velocity to displacement. So the way you would do that is delta x for our first part of the journey is going to be the initial velocity times time plus 1/2 at squared, but this whole part is just 0 because it's a constant velocity. There's no acceleration. So it's just the initial velocity times time. That's 214 miles per hour times 2.1 hours. That's 449.4 miles. And then for leg B of the journey, it's the same thing. You're going to have the initial velocity times time, but the acceleration component of the equation is just 0. So that's going to be 187 miles per hour times 1.4 hours. For that leg of the journey. So that's 261.8 miles. So if we were to graph this real quick, just to see, okay, where should we end up? So it's 449.4 miles at the first leg of the journey is 65 degrees. And the second leg of the journey is at 335 degrees. All right, so 65 degrees is, I don't know, about like this, and it's the longer leg of the journey. And then 335 would be down this way. So my expectation is I'll end up in the first quadrant at a fairly shallow angle. Okay, so let's go ahead and just chart it out. So a sub x is going to be 449.4 cosine 65 degrees. B sub x, not 449, so sorry, be 261.8 cosine 335 degrees. And then C sub x, we will sum those two. So those numbers would be 189.9, 237.3. So that's 427.2 miles. All right, and then for the y direction, just change cosine to sine. right, those numbers are 407.29, negative 110.64, and that's 296.65 miles. Okay, we have our x component, our y component. So let's get the magnitude of vector c. That's going to be 427.2 squared plus 296.65 all squared. Take the square root of that. You get 520.1 miles. So that's part of your answer. And then theta is inverse tangent of y over x. So both of them are positive. We are going to end up in quadrant 1. So no adjustment needed. That'll be 34.8 degrees. All right, so not much different. The only difference is it asked for displacement, and you were given velocity and time, so you had to convert to displacement. All right, let's work one more of those, and then we'll get into the new material for the chapter. All right, 4.2. So that one says a treasure map says that you can reach the treasure on an island by standing at a certain tree and traveling with a velocity of 1.5 meters a second at an angle of 192 degrees for 45 minutes. It then tells you to turn to a heading of 45 degrees and travel with the same speed for 12 minutes. What's the displacement of the treasure relative to the tree? So again, we've been given velocity and time, so we've got to get displacement. Right, so our displacement for part A is, since the acceleration is constant, just like on 4.1, it's only velocity times time. So that'd be 1.5 meters a second. Now we were given minutes. So how many seconds are in 45 minutes? All right, well, it's 45 times 60, right? So that's 2,700 seconds. So be careful to convert it. And that is 4,050 meters. And for leg B of the trip, that's going to be 1.5 meters a second, so same speed. For 12 minutes. All right, so 12 times 60 seconds per minute would be 720 seconds. All right, so that's 1,080 meters. Now I'll go ahead and draw a quick graph. Now your angles here are 192 and 45. Okay, so the 192, 12 degrees below the negative x-axis, so about like that. It's the longer part. And then at about 1/4 the length is up at 45, so it would be kind of like that. So this thing is going to end up in quadrant 2 or quadrant 3. I don't know which. I do know which, but I'm going to pretend I don't know which, because I've worked this problem 15 previous times. Okay. So here we go. A sub x is 4,050 cosine 192. B sub x 1,080 cosine 45. C sub x is the sum of those two. So we've got negative 3961 0.5, 763.7, so that's negative 3197.8 meters. And then our y components, 4,050 sine 192, 1,080 sine 45. And that's negative 842 and negative 7 and positive 763.7. So c sub y is negative 78.3. So we have negative 3197.8 squared plus negative 78.3 squared. Take the square root of that, and you get 3198.8 meters. And theta would be the inverse tangent of negative 78.3. So both components are negative, so we are going to end up in the third quadrant over negative 3197.8. So that's 1.4 degrees. You know that that's not correct. So we have to add, if we're in the third quadrant, 180. So that's 181.4 degrees. So that's our magnitude and direction. So that is not really an important part of this chapter. We already covered that, but it's good to cover it again. And you will have one problem on your test like this. Okay, so it's definitely worth doing the homework and going over. All right, let's get into the meat of the chapter. So stay on page 109. We're going to refer to this diagram. We're talking about parabolic motion. So think of a parabola. A parabola in math, right? A parabola is like this. Okay, well, if you shoot, a bullet, a cannonball, whatever, it's going to go in a curve and so that's like an upside down or a sad face parabola, right? So thus parabolic motion. So let's look at the top of page 2, and all of these bullets are really important. Okay, so I've got them as check marks. A projectile near the surface of the earth presents parabolic motion. This part's really important. The x component of the velocity never changes. The y component is affected by gravity. It decreases until it reaches 0, and then it goes negative. The maximum height occurs when v sub y is equal to 0. We're going to work a problem like that in a minute. If the projectile lands at its launch height, the maximum height is reached at the midpoint of the journey. The final value of v sub y, remember v sub x just doesn't change, it stays the same the whole time. The final value is the negative of the initial v sub y. Now, what am I talking about with v sub x and v sub y and all that jazz? Well, we're going to be using the same three equations that we used in chapter 2. We're just going to split them up into the x and y components. So what are those equations? Well, it's final velocity is equal to initial velocity plus acceleration times time. That was equation 1. Except this time, we're going to look at it from the x component. And time doesn't have an x or a y component. So equation 1 we could also write, if we're just looking at the y component, it'd be like this. So equation 1 we can break into both. It's the same equation, just look at it in the x direction and the y direction. Equation 2, what's that? Well, that was final velocity squared is equal to initial velocity squared plus 2a delta x, but we have an x component for all that. We can write the x version and then the y version. So final velocity in the y direction squared is equal to the final velocity, or excuse me, the initial velocity, voy, all squared, plus 2 times a sub y. Forgot all my hats. Times delta x, displacement in the y direction. So it looks fancy, but it's just the same, and we're just going to break our problems into x and y and do our analysis. And then finally, our third equation was delta x is equal to initial velocity times time plus 1/2 a times t squared. We have the x version of that box. And what's nice is that in parabolic motion, acceleration in the x direction is always 0. So this part of the equation always goes away. Okay, we're not going to deal with that until lecture number 3. But, or no, we're actually going to deal with that in this chapter. Excuse me. So let's write that down. A sub x is always 0. Always 0. And then delta x in the y direction is equal to voigt plus 1/2 a sub y times t squared. Now, you always do have an a sub y. It's always negative 9.8 or negative 32. So a sub y is equal to negative 9.8 or negative 32. All right, with all of that in mind, let's work a couple of problems. So our first one, 4.3, on page 115. Okay, so it says a battleship sinks an enemy ship by firing a missile with an initial velocity of 125 meters per second at an angle of 30 degrees. How long does it take the missile to reach its maximum height? How long does it take for the missile to reach the enemy ship? Okay. One thing to remember here, at max height, the velocity in the y direction is at 0. That's because with parabolic motion, that's a change of direction point. So the velocity, when it's changing direction, for that one moment in time is 0. All right, so this really is a problem where we only have to analyze in the y direction. Now, we're going to come up to problems where we have to look at both the x and the y direction, but this problem, we only have to look at the y direction. Okay, so let's take a look and see what we have. So velocity in the y direction is going to be 125, or excuse me, the initial velocity, v naught y, so voy, if you want to call it that, 125 meters per second. And remember, sine goes with y, so sine 30 degrees. All right, because they're just giving you the initial velocity at the angle of 30 degrees. If you were to, the y component of that initial velocity is what the velocity component that is going straight up. Okay, that's v sub y, that's v sub x. And remember, v sub x never changes. V sub y does change and eventually gets to 0. So 125 times the sine of 30 degrees is 62.5 meters per second. All right, so I need to get time. I have the initial velocity, and we know the final velocity at max height is 0. And then the initial velocity is 62.5. So if I need time, I have the final velocity, I have the initial velocity. Do I have acceleration? Yeah, I've got it. It's negative 9.8 meters per second squared, because gravity is affecting the y direction, not the x direction, only the y direction, the up and down. So if I know these three, final, initial, and acceleration, I can use equation 1. That's final velocity in the y direction is equal to initial velocity in the y direction plus acceleration in the y direction times time. So that's going to be 0, our final, is equal to 62.5 meters per second plus negative 9.8 meters per second squared times time. So doing the algebra, we're going to move that 62.5 to the left. That'd be negative 62.5, and then divide by negative 9.8. All right, and that's going to give you 6.38 seconds. That's how long it takes to get to the midpoint. So that's how long it takes to get to right here. Well, if it takes 6.38 seconds to get to the midpoint, you would just double that to get to its final destination, the end of the parabolic journey. So the whole trip for this missile, it's going to be 6.38 times 2. So that's 12.79 seconds. So that would be part B. All right, so in this case, all of it was in the y direction. We didn't really have to look in the x direction. But we will get to the point where we're having to do both. All right, pause the video if you need to, and we will finish up this lecture with 4.4. All right, 4.4. So I used to take the students to the gym or even outside to try to duplicate this problem. It's basically impossible. I think I had one student basically do this once. So a basketball player lobs a ball over the heads of her opponents to her teammate down court. The player throws the ball at a velocity of 12.3 meters a second at an angle of 65 degrees. If her teammate catches the ball in 2.28 seconds, how far apart are the two players? Okay, so how far apart? What do we want to know? What we want to know is delta x in the x direction. Okay, so what do we know about the x direction? Well, we always know that a sub x with parabolic motion is always 0. So we've got that. We know that time is equal to 2.28 seconds. We can get the initial velocity in the x direction. We'll call that Vox. And that is 12.3 meters per second times the cosine of 65 degrees. Right? So that is 5.2 meters per second. So just the x component of the velocity. So if you think about this, probably we have time, we want to know delta x, it's probably equation 3. Delta x sub x is equal to Vox times t plus 1/2 times a sub x times t squared. But a sub x is 0, so that all goes to 0. So delta x sub x, this ends up being pretty easy. We figured out that it's 5.2. 5.2 We know that the time is 2.28 seconds. So how far apart? That's 11.86 meters. So what I used to do is take the students to the gym and put them 11.86 meters apart and see if they could throw the ball to another person and it stay in the air 2.28 seconds. And it's impossible in the gym because you hit the ceiling. You have to throw it so high. We went outside to do it, and usually the person throwing the ball would miss the other person because neither person was allowed to move. But I did have one student pretty much throw it exactly correct. You really have to launch it way up in the air to get the ball to stay at 2.28 seconds. All right, so homework number 1 is going to be review questions, page 138, 1 through 6, and practice problems, page 139, 1 through 4. Okay, good luck on those, and I will talk to you next video.